Hello everybody. Okay, in this video I will explain how we can program Maya Python to create some geometry like this. Okay, so first of all, let's look at this picture. We have done something similar, right, in our previous exercises. Okay, so but let me show you how I can build this. So first of all, let's again import. Let me increase the font size so you can see clearly. Okay. In my Maya layout, right, I actually dock my script editor here, right? So I can see both my 3D view and my script editor, right? This way, and then I close. I turn off all the display of unnecessary shelf and time slider because I don't need those. Yeah, let's get back to scripting. So when I import maya.cmd, maya.command as cmd, now I can use command. But first of all, I like to create an empty list to store all the object names, right? So later, at the end of the script, I'm going to group them into one group. All right. So I'm going to also use variables, right, to specify, for example, how many. Let's look at the picture. How many cuboid we need vertically. For example, in my case, it looks like 100 cubes we need, right? So I would say my max range 100, right? So later I can change this variable value, so everything will be changed also. Yeah. I can also specify another variable, say the length of the cube. Right. So we can change it later also. Then I'm going to create the, say, let's take a look at the center part. Okay, I think you know already how to do the spiral staircase, but we need to combine with another algorithm to reduce the length of the cube along the way vertically up. So let's first of all, let's create a for loop. Say I'm going to run, in this case I'm using num. You can use whatever variable, say I, but don't use reserved keywords. Right? So for num in range, max range, right? So we're going to create a range of 0 to 99, so 100 objects, right? And I'm going to first of all create polycubes, right? Cube equal cmd dot polycube. So this way, I'm going to create a default polycube, which is 1 by 1 by 1 unit in 3 dimensions, right? So it's 1 unit polycube, and then it will create return you a list of names. The first one is the transform node. The second is the mesh node, right? Yeah. Then immediately after I got this information, I can do what? I can append this name, the transform node name, right? Cube 0 to this list of all the objects. Immediately append that. Okay, so now let's go step by step. let's build let's stack the cubes vertically. So I can do, after I create the cube, I move up, right? Move it up, say in the x direction would be 0. In the y direction would be something to do with num, right? So num is the index of the of each cube. So the num, and I just say num first, right? 0, xyz, and the name, right? Cube 0. Right? Yeah. If you run this code now, oops. Oh, I forgot the ending parentheses, right? Yeah. If you run the code now, yeah, you get this. You get 100 cube stack. It is. Okay, so it's all good. So next, I'm going to scale the cube in one direction, right? Yeah. So I'm going to add the code. Command dot scale, right? I'm going to scale it in x direction, right? Yeah. So I'm going to say length, right? Because I have the length here, I can use this. So the y is 1, and z also 1. Okay, and the name. Oops. Cube 0, square bracket. Right? So I can delete all this, select all this, delete them. But in the end, I like to add one line of code to group everything together. So next time I can just directly delete the group. Right? Very easy. So I can do command dot group all objects. Right? If I run, I get this. Right? And everything is grouped under one node. I can delete this. Okay. So that's so far what we have now. Next, I can either do the Christmas tree shape, right? At top is very short, at bottom longer, the Christmas tree shape. Or I can rotate this, make it spin, right? Like spiral staircase, right? It doesn't matter which one I do first, but maybe I do the rotation first, right? So I have the move, I have the scale, I can now rotate it. But let's take a look at the image first. The cube is rotating around a pivot point, which is located at one end of the cube. All right, so you're not at the center. So we need to modify the code a bit so that all the cubes, right, I manually do first now. So all the cubes will be moved aside, right? And then when we rotate, we don't rotate around the center. We change the pivot point. Oops, sorry. We change the pivot point. Then when we rotate, it's around the word origin, right? Like this. Okay, so that's the idea. But in the code, how we can do that is this. Basically, I'm going to first of all move all the cubes in x direction for half of the size, right? So I'm going to change this 0 to length divided by 2. Length divided by 2. Better do 2.0, right? In case in a current situation, the length is integer, right? Yeah. You may end up with integer that when you do integer division, the end result is not it's still an integer that will ignore all the decimal digits, and you end up with not accurate result. So you can do it 2.0, then everything will be convert to float number and do the division, right? Everything will be very precise. So let me delete this. Right, what do you have? Yeah, so all the cube will be pushed to one side. Now we can rotate one by one, right, by different degree. So rotate around y-axis. So 0 is x is 0, and y-axis is different value, but the value has something to do with the index number, right? So the index multiplied by 10, right? So the increment for each cube is 10 degree. So around z, no, right? Then the name cube 0, right? Delete this. Yeah. Okay. So this is something that wrong because it's still rotating around its center, right? But we want to the cube rotate around the word origin, so we need to change the pivot point. How to change the pivot point? In the code is very easy. We just specify the pivot point parameter. Okay. So for the rotation, I'm going to add pivot equal square brackets 0, 0, 0. All right. This is the center for the rotation. Run again. Yeah, we get this, right? Same spiral staircase. This is something we already done previously, right? It's nothing new. But again, now let's take a look at how we can reduce the size along y-axis until it goes to maybe 0 in the length, right? Yeah. We can use the scale function, right? Yeah, to change the scale. But what would be the equation or formula to do that? Okay, so we can create another variable. Okay, I don't want to make a super long formula here, right? Type a lot code here will be very confusing. So I'm going to create another variable called size. It can be equal to length first, right? So I put size here, right? So the size equal length, and then I use size here means I use the length here, right? So same as before. I don't need to run the code. When I run the code, rerun the code, it will be still the same. Okay, so next, it's all about changing the size of the. This size means the set in one direction. Okay. Okay. So it's all about changing the size of the cube, right? So how we can do something like, shorten the length. Okay, first of all, let's do a reverse Christmas tree, right? How to do a reverse Christmas tree? We can say, if you're at top, you have the full length, right? Yeah. Then, if you're at bottom, you have a 0 length. Yeah. So which means that if your index is 0, of course, you can multiply by 0, it becomes 0. But at top, your index is 100. But this could be changing because your max range for now is 100. Later could be 200. So how can we change this number to make it into number 1, right? We can do a division, okay? So your current number index, which is the index, divided by length, right? The total length. Oh, sorry, not length. Max range. Yeah, it will be your. Actually, it's the normalized index, changing from 0 to 1. Okay. Yeah. But again, if you do integer division, you get a very vivid result, right? Because this num always smaller than max range, you end up with all 0. So you have to do what? You have to convert using a float function, right? I think I give you the hints for this one. So you need to use the float number, a float function to convert the number from integer to float. Okay. So now let's run this. Look at this. Right? Yeah. Very beautiful, but it's the other way around. Right? Yeah. Again, this has another issue also. When you scale it, right? It scale around a center also. It's not around the work origin, or I would say y-axis. So we need to put the pivot point here also. Right? You can do okay. Here's the okay. Let's try this first. Will that work? Okay, let's delete this group. It doesn't work. Oh, it doesn't work because okay, because when you do this, okay, imagine we are the computer, right? We do one by one. Your first okay, we got one thing wrong. See, this is how I debug my code. I found something wrong. I disable the code, and I realized here I use the length, but the length is no longer the actual length. Actually, the size is. So I need to change this one to be size. Okay. Right. Remember later, for this line of code, I changed the length to size, but for this one I forgot. Right. Yeah. And then they give me this weird result. Then I disable the code to debug. Right. Debug means troubleshoot your code. Right. So I disable this too. I check if the move will work. Just now, even the move doesn't work. Means that something is wrong with it, right? So I realized, oh, okay, I'm still using the length, but actually the size is the actual one, right? Yeah. So now if I run the code, I get this. Okay, let me see. Up size divided by 2. Okay, so for num is 0, this becomes 0, right? So the size is 0. Then this one doesn't move at all. Yeah, correct. This is correct, right? Yeah. Let me see. Yeah. Then if I enable the scale, okay, remove the pivot point. Okay, the reason why I remove the pivot point is this. You can how can I explain this? Okay, so basically we can try the code one by one. Okay, this is how you debug the code. All right. Oh yeah. Of course, I need to move. Okay, I tried move not in X, only in Y first. Okay. Okay. So this gives you something like this, right? So I decide the size, right? I can scale it first, right? So actually the order of the code, right? It will affect the end result. Okay. So in the end, the code can end up with a different script. There's no one way, but again, you need to understand how you're going to how is your approach, right? So for me, I can do move first. I can do scale first. So if you want to do scale first, you can try this way. So for example, I scale it first, right? Scale the size 1 1 around this center. I'm not setting the pivot point for the scaling, right? Then I move it up, right, like this. It looks like, yeah, there. But again, I can do just one little thing. I can push the cubes to one side, so they have a line on one end. All right. So what I can do is this. I'm going to move this object in x direction for the half of the sides, right? Yeah, correct. Yeah. So now you have this. Okay. Because the reason why I disable the rotation and all this is to don't confuse you with the rotation, right? Yeah. So I want to give you this first. This one you already seen this in my previous example. Okay, so how to reverse it? Okay, very simple. So for this length, right? You look at this number, right? This one at bottom is 0, at top 1, right? Multiply by the length. But how about I reverse this, right? So at bottom is 1, at top is 0. So what I can do is just 1 minus, right? If I 1 minus 1, bottom becomes 0. 1 minus, no, sorry. 1 minus 0 become 1 at bottom. 1 minus 1 becomes 0 at top. Okay. Yeah. So if I delete this, I run this, so I reverse it. So now, okay, now this line of code, I can see that I can just add in the rotate. Now this will work better. Yeah. Yeah, if you want to do move first, right? Later you can try yourself. Before the scale, right? You have to do something extra here, I believe, to compensate the scale you have done previously. But this way is much easier, much easier. Okay, so for the rotation, same. Rotate around 0, 0, 0, right? So if I just run again, yeah, we have this, right? Yeah. So the center part is done, right? Then let's do the outer spiral staircase with different frequency, it looks like, right? Okay, so for this one, you can do it here, right? In the same for loop, or because anyway you are iterate through 100 objects, but you can do another one if you feel like you are confused. So I will do the simpler way, create another for loop, so you don't mix these two together. You can if you are very confident, right? So I do again, one num in range, right? This I also create a cube, right? Yeah. And immediately also I also append this cube 0 to the list here, right? To the all global list. And next, I'm going to also do the same thing, right? Because I don't have the code, I have to try. So bear with me if I halfway change my method, change my approach. Okay, this is not like I don't know what to do. It's like when you do, you know that, oh, okay, the scale maybe go first, then you end up with an easier solution, right? Yeah. So that's my thinking process. Okay, so for this one, right? Yeah, I need to give it a try. I don't know approach yet, but say for example, at least I can move it up, right? Let's say reduce the size, right, and spin it. But as for offset away from the center, let's see how we can do it. So basically, we're doing the same thing right here. So I also use a size, so we can actually copy and paste all this code, right? Control C, copy, Control V, paste here, right? Of course, if you run this code, you end up with two sets of queues that exactly match each other. I don't want to do that. So how to differentiate a little bit is that we can rotate this cubes, right, differently. For example, I rotate 20 degree, for example. Right, so I delete this one. Right, yeah. You end up with two sides. But how to move this one away from the center? Let's try. Let's see if we can add something here. For example, if I add a number plus 10, right? Just same number for all of them. You can imagine the result. So all of them will be pushed away from the center for 10 units, right? Yeah. But let's see. Then we can tweak from there, right? So I add this number to the X. Yeah. So you end up with the center part still remain the same. The outside at bottom move 10. Not enough, right? Yeah. I should move until here. But at the top, it moved too far away from the center. It shouldn't move. So it's like, oh, the offset at top is 0, at bottom is the length, right? Which is 30. Yeah. So how we can do that, right? Yeah. We have this size. Yeah. Can we do that? Oh, actually the size is just the value we want to use, right? At bottom 30, at top 0. Yeah. So instead of use the 10, I use size. So size divided by 2 plus size, right? Yeah, let's try. Yeah, that's exactly what we want. Okay, it's different, slightly different from this one, but don't worry. So let's tweak the look. Maybe the length is not 30 anymore. Okay. Or maybe let me see. Oh, it's okay. Okay. For example, okay, one thing we can do is oh, we can do this. We can make the cubes taller. Okay, a bit taller. So for the scale in y direction, I want to scale 2, all right? Just make it taller. You can do it here. When you create a cube, you can also just scale it. Yeah. So scale also this one, become 2. Then they will overlap, right? Because when we move up in y direction, we move 1 unit. So now we need to multiply by 2. Yeah, multiply by 2. Yeah. So now it looks like we have created something that we want. Okay. So yeah, so that so back to the code. how can you decide what kind of code you use and what other values you're going to use, right? It's by observing the design you're going to do, right? And then approach the target step by step. Say I scale it first, or I move it by how much first. Then I see, oh, actually, I want to, the bottom, I want to move the length. At the bottom, the top, I want to move 0. Then the size is the one. Yeah, I can just use it here. That's it. Problem solved, right? Yeah. So I think that's the thinking process for this exercise. Hopefully you understand better, right? Okay, so that's all for this code. Okay, for those who can merge these two for loops together, yeah, please do so. You can try and you can learn something new also. Yeah, because you have duplicate code, how to make them unique, right? Don't overwrite each other. It's also a challenge. So I leave it to you. Okay, that's all for this video.